Alright, this is part 4 of our lesson on solving quadratic inequalities and graphing them. Alright, the first thing we need to do is factor this so we can find out what the x-intercepts of this parabola are, the zeros of the function, if you will. So we're going to add 2 to both sides. Hold on. We're going to add 2 to both sides, so that's going to give us 4x squared minus 9x plus 2 is less than 0. Now let's factor this thing. Okay, let's see, 4x squared, so that's going to factor, at first I was thinking maybe it's 2x and 2x, okay? But then I looked at the 2, and I knew that there's only one way to factor 2, and that's 2 times 1. Now, no matter where I put this 2, it's going to make a common factor, a GCF. And so I know that's not going to work. So for that reason, and I was doing all this in my head, but for that reason I decided to go with 4x and x instead of 2x and 2x, because that way if I factor the 2 as 1 times 2, there's no GCF. Now here again I wouldn't put the 2 on the left because that would still make a GCF. So this is our best bet. Remember, inner plus outer has to equal middle. Inner, right now I have 1x. Outer, I have 8x. So this is looking pretty good. I want negative 9. To get negative 9, I need a negative 1x and negative 8x. That will make negative 9x. That means both of these would have to be negative. There's one more thing we have to check. Are we getting the correct sign on the 2? Well, yes, because negative 1 times negative 2 is positive 2. So we have factored it correctly. Now I want to find the zeros of this function. Okay, the x-intercept. So I will do that by setting these equal to 0. So I will go 4x minus 1 equals 0, and I will go x minus 2 equals 0. Alright, so adding 1 to both sides will give me 4x equals 1. Alright, just one like that. And adding 2 to both sides will give me x equals 2. Now here I need to divide both sides by 4. Okay, so that gives me x equals 1/4. So this is one of my x-intercepts, and this is the other one. Okay, 1/4 and 2. Let's go ahead and graph those on the number line. When we do, looking at the symbol here, will we be doing open circles or closed circles? Yeah, open circles. Alright, these numbers represent where the graph equals 0. But we want to know where the function is less than 0, not equal to. So we need to leave the endpoints out, and we'll do that with some open circles. Now, my graph, I did not put all the numbers on there, because I'm going to keep the graph simple. So make sure you put 0 on your number line, okay? And let's see, I'll call this 1/4, okay? And we have 1/4 and we have 2, okay? So I'll just put 2 right about here. Okay, those are my x-intercepts. Now I'm going to put a couple circles, circles at 1/4 and at 2, and like we discussed, we'll leave those open. Now your teacher, if it's not me, if I'm not your teacher, other people like to put these x-intercepts like right on the line, you know, because that's where they are, but it makes it hard for me to see your arrows, so I'm gonna ask you to leave it above the number. Anyway, for my visual learners, look, I want to show you how you can come up with the answers in like 30 seconds, okay? But then we'll go back and do the test values like normal. But looking at this equation, you see that we have a parabola, okay? Not only that, but it's an upward facing parabola because it's positive. So looking at this number line, you could imagine your parabola doing something like this. Okay, you have this upward facing parabola, it has these x-intercepts. Okay, so it's doing something like this. Okay, now we want to know where the function is less than 0. Less than 0. Okay, graphically, less than 0 is going to be the part of the parabola that's below the x-axis. In other words, this part of the parabola, all right, less than 0 means below the x-axis. So in terms of the x-axis, we're talking about x values that go from here to here. That's the part of the parabola that's below the x-axis. It's the part of the parabola that's between 1/4 and 2. So that's how you could get the answer in 30 seconds. Now, we're not going to do it that way. That was just for my visual learners. We're going to use test values instead, because that's the way we're supposed to do it. And some people are not so visual. Okay, so what we are actually supposed to do is realize that these zeros, these x-intercepts, divide the number line into 3 zones. We have this yellow zone, which goes forever, and we've got this blue zone that goes between 1/4 and 2, and we've got this, let's say, all right, will this work? Let me try this. We've got this is pink zone. Okay, we've got the yellow, the blue, and the pink, 3 zones. So I like to make a little chart out of this, okay? So do it the way I'm doing it. Okay, in each one of these zones I need to pick a test value. Alright, in the yellow zone I'm going to pick 0 because 0 is just fun to work with. It's fabulous. In the middle zone here, between 1/4 and 2, the only integer in there is 1, so I will definitely use that. Now in the pink zone, or red, or whatever you want to call it, anything bigger than 2 will work. I'm just going to use 3. Okay, so these would be some good test values to use. Now I need to substitute these values back into the original inequality. However, I like to use, what do I like to use? I like to use the factored form of the inequality. So let's see, 4x minus 1 times x minus 2. Okay, so here I go. 4x minus 1 times x minus 2 is less than 0. So that's what it was, right? Okay, and I'm going to put that in all 3 spaces. 4x minus 1 times x minus 2 is less than 0. 4x minus 1 times x minus 2 is less than 0. Okay. So I'm going to now substitute in my test values and see which zones have make true statements, which zones have the solutions. Alright, let me just set this up here. Alright, I've got 4 minus 1 minus 2 less than 0. Alright, I'm just leaving a space so I can substitute this in colorfully. So I'm plugging in 0, so 4 times x becomes 4 times 0 minus 1, and then x minus 2 would be 0 minus 2. Alright, you get it. You see what I'm doing here. Now this is just going to become 0 minus 1 times 0 minus 2. Okay, because 4 times 0 is just 0. And then this is just going to be negative 1 times negative 2 is less than 0. Now a negative times a negative is a positive, so that's going to make positive 2 is less than 0. So, is this a true statement? Yes or no? Is 2 less than 0? No! 2 is not less than 0. That means x equals 0 is not a solution. That means none of the values in the yellow zone are solutions. So I will show that this zone has no solutions by leaving this area blank. Just leave it empty. Okay, meanwhile, all right, I'm going to do the same thing for x equals 1. So I've got my 4 minus 1, and my minus 2 is less than 0. Okay, so I'm substituting in 1. So I'll do 4 times 1 and 1. Okay, well look, 4 times 1 is just 4. So that's just 4 minus 1 and 1 minus 2. Okay, 4 minus 1 is 3. 1 minus 2 is negative 1. Okay, and a positive times a negative is a negative. And then I ask myself, is this a true statement? Is negative 3 less than 0? Well, yes, it is. Negative 3 is less than 0. All negative numbers are less than 0. That means that x equals 1 is a solution. That means that all values in the blue zone are solutions. Okay, and we will show that all of these values are solutions by drawing a segment between these 2 points. All right, this segment represents all the solutions that's in the zone formerly known as blue. Okay, let's do that one more time with x equals 3. Okay, so I'm substituting x equals 3, so that makes this 4 times 3 and 3 minus 2. I'm just putting 3 for my x's. Okay, so that makes this 12 minus 1, 3 minus 2. Okay, 12 minus 1, so clearly that's just going to be 11. 3 minus 2 is 1. 11 times 1 is 11. Okay, is 11 less than 0? No, 11 is not less than 0. That means that x equals 3 is not a solution. That means that none of the values in this zone are solutions. I will show that none of these values are solutions by leaving it blank. Now notice that the interval that we end up with is the same interval that we got graphically at the beginning when we looked at the parabola and we said, okay, if we want the part that is less than 0, that's the part that's below the x-axis, and the part that's below is the part that's between between 1/4 and 2. So my visual learners will be able to come up with this answer in 30 seconds, and you still have to show your work. Okay, you're asking, why, Mr. Burton, why do I have to do this? I don't have a great answer for that, but this is the way that they want me to teach it to you. So you got to show your work like this. But at least if you make a mistake, you'll know, because you'll know ahead of time what the right answer should be. So I think it's still helpful. Anyway, the solution. Now this time, let's write the solution both ways. We're going to do it in interval notation and as an inequality. So interval notation for this graph would be very easy because it's just going to be, it goes from 1/4 to 2. So I just put 1/4, comma 2, and we'll leave it round parentheses to show that the endpoints are not included. All right, for the same reason we have open circles. Now, we can also do an inequality by doing it this way. If I want to show all the values between 1/4 and 2, well, this segment we'll call this the x values, the solutions. And what we'll do is we'll say 1/4 is less than x, which is less than 2. Okay? That's how you would write the solution as an inequality. All right? It just means all the values between 1/4 and 2. Okay? So you need to be comfortable and familiar with both ways of writing the solution. Okay? You know, interval notation, just like we do domain and range, but also inequality. Because on a multiple choice test, you might see either one of these, and you have to be familiar. All right, that's the end of this video. If I have time, I will try to come back and do problem number 5 in another video. Thanks for watching. Hope it was helpful. Mr. Helpful, not hurtful.